So in this case, we are going to consider the question based on the second moment of area as we had our introduction. So we're just going to try and apply the formulas that we have already covered before. So we are given here, calculate the second moment of area of the area bounded by, all right, so the first question, which was the curve of x is equal to y squared. And we are given x is equal to 3 and y is equal to 0 in the what? First quadrant. So you're considering the first quadrant. All right, so first let us consider the sketching part of the graph. So we're going to take it about the x-axis and also about the y-axis. Okay, so if you are going to sketch this graph, it was easier if we have it since we have got the limits here for x. X is equal to 3. Take note, when y is equal to 0, it simply means x is equal to what? X is equal to 0. So it was best for you to just have y as the subject of the formula. So from that, y squared is equal to what? Y squared is equal to x. So you can simply introduce the square root. We are used to this one, to the graph of the square root of what? The square root of x. So in the first quadrant, we are going to consider, all right, in the first quadrant, our graph was going to be like this, all right? So for y is equal to the square root of x, for each value that you're going to consider, it's going to give us two possible values of y when x is 0, when x is 1 plus or minus 1. So there were going to be two possible values that you are having. So this quadrant is not necessary because we are focusing with what? The first quadrant. So you're just going to consider your sketch in the what? In the first quadrant like that. All right. So this is the graph that we are going to consider for y is equal to the square root of x from that x squared. So this is the square root of x. The limits now, as I said, when y is equal to 0, x is what? 0. So you're starting from that 0 up to where x is what? Up to where x is 3. So this can be the limit, the line of x is equal to what? Of x is equal to 3. So that will be the limit. So from here, these limits that we are having as we are working with the x, we can use that as the limits. Instead of going back to the y there, you can just focus with what? The x values, and that's gonna give us what? The representative strip for x. As the curve is given between what? The curve and the x-axis, between the curve and the x-axis. So you'll be taking in between 0 and what? And 3, from 0 to 3. So that's what you are going to simply consider on your what? On your calculations. You can consider this as the line x is equal to 3. So the line x is equal to 3. In calculations, it does not affect us in calculations. So that line of x is equal to 3. In calculations, when you put it this way, you can ignore it in calculation and have it direct as a limit. Yes, it's a graph that you can consider to say, okay, it's between this graph, but guys, you just consider that way, and those will be your limits. So meaning to say, that is what you're going to have as the sketch, all right? So then from here, we can have the first one, that is 1.1, considering what? That we are dealing with the x-axis. So the second moment of area with respect to x, with respect to x. So that's why we go back to those formulas that we had in the previous class with respect to x, and the strip is for what? The strip that we are given is for x. So these two, the x-axis and the strip, they are what? perpendicular to each other, then we formulate. So in this case, guys, I'm not going to formulate again these formulas as we wrote this before. I'm just going to take it here from here, the curve and the x-axis. For us to calculate the second moment of area with respect to x, remember, this is the formula that we ended up with. So you're going to take it from here to here up to the formula that you had, all right? So meaning to say, there I'm just going to write the formula that we are having with respect to x so that we do not waste time. We already formulated these where they were taken from, where they were being what? Taken from. So we saw that from the formula r squared dA, it is going to give us 1 over 3, the integral of what? Y cubed. So that is what we formulated from our previous class. Okay, so that is what you simply have. So y cubed, y being f of x, that is y is equal to what? To the square root of x, which simply means x to the exponent of a half, 1 over 2. So that is, you can rewrite this as a third, the integral of from 0 to what? From 0 to 3. You have used it as a line, as a graph already. So that's what you're going to have. And y cubed, that's y in terms of what? In terms of x. So this one, that's x to the exponent of a half. So that was going to be x to the exponent of a half, but being raised to the exponent of what? Of 3. So you multiply this, that's x to the exponent of what? 3 over 2 with respect to x, just like that. So basically, that is what you're going to have, and you can simply integrate this with respect to x. So let us add 1, that's x to the exponent of 5 over 2. So it's going to give us 5 over 2 over 5 over 2. So this is it. So this is simply here 2 over what? 2 over 5, x to the exponent of 5 over 2. So this one is going to simply multiply outside the 2 over what? 5. Then we're going to take this x to the exponent of what? 5 over 2. Then we have our limits just like that. So this is how we can simply play around our questions when they are given on the second moment of area in terms of the exam. All right, so we're going to add up more questions as time goes on. So here multiply, that was going to give us 2 over 15. Then let us put our limits in place of x. That's 3 to the exponent of 5 over 2 minus the lower limit, which is just going to give us what? A 0, this one. All right, so that is it. Multiply. That was going to give us 2,078. And the units for the second moment of area will be what? The units to the exponent of what? 4. All right, to the exponent of 4. First moment to the exponent of what? 3. Second moment to the exponent of what? Of 4. So that will be what you will be having on the what? On the second moment of area with respect to the what? To the x, that is, you are working with the x-axis as your reference. Then another part, it was with respect to the what? To the y-axis. So just like before, we are going to need the formula. So this time, that's with respect to the what? To the y-axis. So we consider according to what we had with the representative strip for x, all right, from our formulas, with respect to y, this is what we ended up with on our formula, remember, from here. So that's x squared y. So that was going to give us the integral of what? X squared y. Okay, dx. So that's it from A to what? From A to B. So the y in terms of what? In terms of x, that's our f of x, the function that you're already given there, which is what? X to the exponent of what? A half. So that was going to be the integral of from 0 to 3 of x squared times y in terms of x, that's what? X to the exponent of what? A half with respect to x. So here, guys, it's already in terms of x, so there's nothing that you are putting there or substituting. So you're going to integrate All right, so for us to integrate, we can combine these two from the laws of exponents simply because the bases are the same. Add 2 plus what? 2 plus 1 over 2. That was going to be 5 over 2. So that's 5 over 2. Okay, we can integrate this, add 1, that's going to be what? 7 over 2. So that's 7 over 2 again, which is 1 divided by 7 over 2 is what? 2 over 7. X to the exponent of what? 7 over 2. So you can put the limits as you are given. So that is how you simply play around these typical questions as you are given here. If you are going to substitute the limits as we are having the x value being 3, so that's 3 to the exponent of 7 over 2 minus what? A 0. So that is what you're going to have at the end of the day. So let us simplify this. That was going to give us 13,362. All right, as we are dealing with the second moment of area, units to the power of what? 4. So that's how you play around with these calculations. So what you simply have to consider is the graph that you're given. Is it between the x-axis and what? Okay, you consider that as we had all these, so consider each and every section already. You have the formulas, so just have the formula, put into the formula, work with the formula. So this is what you're going to do for each and every part that we are seeing, each and every part that we are seeing from these formulas. So just go through revisions and question papers. If you see any part that does not tally to what I have explained on these introductions, then let us communicate so that we can have a revisit on that section for revision purposes, all right? But let us do continue enjoying the membership for you to access the rest of the videos in the playlist, all right? But for now, that is it. Till we meet again.